students, today in this lecture we will study about single phase series circuit. In DC circuit we have simple formula that current equals to I equals to V upon R. For DC circuit it is not variable, it is constant, but in AC circuit this is not applicable because here current and voltage is always varying, and due to variation electromagnetic field is set up in the circuit, and hence inductance, resistance and capacitance is also variable. Due to that current is varying. So in single phase AC circuit we will deal with a pure resistive circuit, inductive circuit and capacitive circuit, its phasor and its power relation. First of all we will study about in pure resistive circuit. Here we see that a single resistance, pure resistance, is connected with a AC source Vm sin omega t, that is Vt, and current is flowing across the circuit. As we know the basic principles, voltage drop across R equals to V equals to IR, that is I equals to V by R. Here we have taken the reference V equals to Vm sin omega t, that is It equals to Vm sin omega t upon R, and this value is called Imax sin omega t. We will convert it into phasor. As already I have told that RMS value is converted, RMS value is written in the phasor form, that is RMS value of Vt sin omega t equals to V, capital V equals to Vm by root 2 angle 0 degree, and I equals to Im by root 2 angle 0 degree. Here also comes that phase current is also in phase with the voltage. So phasor diagram we can draw the phasor diagram. V is taken as reference, and in this phase current is also coming, that is V by R. So we can see that current is in phase with voltage, and whose phasor diagram is this, and whose time response diagram, sinusoidal diagram, is represented by this. Here we see that V has a sinusoidal representation and current also comes sinusoidal, Im sin omega t, and power we can derive that P equals to Vi, that is Vm sin omega t, Im sin omega t, and it is that also power is also a sinusoidal representation. So here is the derivation of power, which average power is equals to Vi or V RMS or I RMS. It is RMS value. Pure inductive circuit. Here we see that inductance is connected in series with the sinusoidal applied voltage Vm. As we know that according to Faraday's law of electromagnetic induction, here in the coil EMF is induced, which equation is given by minus L di by dt, and L is the inductance of the coil. But it also property that induced voltage is equals to the applied voltage and it is in phase opposition, that is opposite to the magnitude of applied voltage. So from here we can derive I current equals to Vm upon root under Vm by L sin omega t d omega t. By integrating we can calculate current I from here, and I equals to Vm sin omega, Vm upon omega L minus cos omega t, and this can be converted into sinusoidal, that is omega t minus pi by 2. So we can write it in phasor form, as V is taken as reference here, V. So we can write it in phasor form, that is V equals to Vm by root 2 angle 0 degree, and I equals to Im by root 2 angle minus pi by 2, that is here, from here minus pi by 2. We can draw it in phasor, that is we have taken V as a reference and induced EMF is equal and opposite to the applied voltage, and current lags the voltage by pi by 2, that is current is downward direction. So we can say that current lags the voltage by pi by 2, or in the another statement we can say that voltage leads the current by pi by 2. So we can say that in purely inductive circuit, voltage leads the current by pi by 2. Now for pure capacitive circuit, here we see that a capacitance is connected with a source, AC source supply, that is, and we can find current I equals to C dV by dt, as I have already told. So we can differentiate this V and we can get this value. So Vm upon 1 upon C omega sin omega t minus omega t plus pi by 2. This cos omega t is converted into sinusoidal function, as our source is a sinusoidal function. So from here we see that voltage is also sinusoidal and current is also sinusoidal, but voltage is taken as a reference 0, or here coming as plus pi by 2. Now this 1 upon omega c is called the capacitive reactance Xc, represented by Xc. And unit of this Xc is ohm, when omega in radian per second and C in farad. Radian per second and C will be in farad. Then its unit become ohm. Now we can draw the phasor diagram, as V is taken as a reference, Vm by root 2 angle 0 degree, and current comes here is Im by root 2 angle pi by 2 plus pi by 2. So we have drawn that V as a reference and current leads the voltage. So we can see the statement: in pure capacitive circuit, current leads the voltage by pi by 2 and voltage lags the current by pi by 2. Here I have skipped the topic. One is topic that here you have here it is coming that I equals to Vm upon omega L minus cos of omega t. This omega L is represented as XL and it is called inductive reactance, and its also unit has ohm, when omega will be in radians per second and L in Henry. So I was saying that XL, unit of XL is ohm, when omega in radian per second and L will be in Henry. Here we can draw a sinusoidal function, as a voltage is a sinusoidal and current is a cosine value from this cosine value. So in single phase AC series circuit, we can say that resistance, for the pure resistance, current is in phase with voltage. For purely inductive circuit, current lags the voltage by 90 degree, and for purely capacitive circuit, current leads the voltage by 90 degree. Thank you.